I apologize for going on for 3 videos, but I kind of slowly walked through everything, so hopefully it makes sense and there's very little confusion on this one. You should have some familiarity with rotating things around an axis if you're going through this calculus video, okay? So anyway, so I have 2 pi, right, times the integral from 0 to r of r squared minus x squared dx. Okay, and what does that become? Well, I'm integrating over x, right, the x-axis. So I basically have the integral of r squared minus x squared dx, and I'll put my 2 pi out here, is the same thing as r squared x minus, x cubed over 3, right? And that's all going to be evaluated from 0 to r, like I said before, 0 to r. Okay, so what does that become? Well, if I plug in an r there, right, I get r squared times r, so I get r cubed, right? And I plug in an r here, I get minus, and I plug in an r for this x, I get, again, r cubed, but it's over 3, right? All of this times 2 pi. 2 pi. Now, the reason I don't really care about this 0 is, well, what would happen if I put in a 0? Well, I'd get 0 for this guy term and 0 for this term. 0 minus 0, which is just 0. And that thing minus 0 is just that thing. So I get all that, which is basically, okay, how do I look at this better? Okay. Well, r cubed is really 3/3 r cubed, right? Let me keep the yellow for r cubed, and minus 1/3 r cubed, right? Okay. All right. Fair enough. So now I have 2 pi, and what I'm going to do is I'm going to pull out that r cubed, right? 2 pi r cubed, and then I'm going to keep what I had in the inside, 3/3 minus 1/3. All right. Okay. Hopefully, if you remember the volume of a cube of a sphere formula, you might see how this is starting to turn into it. Okay. So that obviously 3/3 minus 1/3 becomes 2/3, right? And I had 2 pi r cubed, right? And if I'm going to multiply these together, I'm going to really concerned about multiplying the, actually let me do this in this color. I'm going to be multiplying this 2 with this 2, and it's going to come out to 4/3 pi r cubed. And that's how you get the volume of a sphere from integrating.